We've learned who viscosity is, the value props of integrating Oracle ATP-D into a transitional architecture. We've taken a detailed look at some of your business use cases. Is there anything else that you'd like to share with us today?
Well, I do have this brief demonstration of exactly how automatic indexing optimized a rather intense TPEC hybrid workload by well over 2 orders of magnitude, all without flicking even one switch. I think our viewers might find that a little bit interesting.
Yeah, I think that would be interesting to see. So why don't we do that? Jim, why don't you take it from here?
Okay, I will. So let's take a look at the extreme test drive we did with ATP-D. The first thing we had to do was prime the pump, which meant we had to build the TPCE simulated workload with PL/SQL so that we could handle the transactions that 33 table model and this spaghetti diagram of functional implementation actually required. I used MonitorDB to keep an eye on what was going on just before I went ahead and started my 2 workloads. One was an OLTP or DML specific workload, and one was a read-only reporting workload. So here's the first one starting up. You can see that MonitorDB recognizes that, something is happening here, and some CPU utilization is definitely kicking in. I also leveraged the new SQL Developer web console to keep an eye on what was going on inside the database instance at this point. So you can see here's our CPU starting to crank up here, and I can scroll down a bit and see that the individual SQL statements that are contributing to this, including the individual sessions as well, that are contributing to this rather significant uptick in workload. Now, I can also drill in to an individual SQL statement. That one's of particular interest because it sure looks like a query, but I thought we're doing DML here. Well, the answer is, yeah, actually several of these DML facets, if you will, of the workload, and this one called trade result transaction, actually require significant amount of querying against the database to find the data that it's going to update. So we're able to keep an eye on it that way, but now what I want to do is take a look under the covers. You're going to see automatic indexing here kick into gear. Hold my beer, watch this. First thing to understand is automatic indexing is a methodology. It's an expert system that uses reinforcement learning to determine which indices, secondary indices, might be valuable. But it doesn't implement them and actually create them until it actually proves it out. So let's take a look underneath the covers. First off, automatic indexing is already enabled on ATP-D. I didn't turn anything on. But right now, since the workloads have just started, there's no activity recorded. However, after the first run of automatic indexing, guess what? Here are several indices, but note they're all marked invisible. Why? Because we haven't proven yet that they're valuable. After 30 minutes, both the DML and the query local workloads complete. And now, what are these spikes? Well, they're actually automatic indexing going back in and determining which indices are most valuable. At the end of the second run, again, only another 20 minutes later, automatic indexing decided that these indices were valuable. So to get a deeper look at what automatic indexing actually decided, I generated a report that shows at the summary level well over 600 times performance improvement for the indices that were created. And here are some of them. Notice the asterisk ones are the ones that are still invisible. So here's another statement level look. We have 3,400 times performance improvement, a dramatic change in the optimizer cost from over 300,000 to a mere 8. Here's another statement. So it's not that impressive. Yeah, it's only 400 times improvement. Still, not insignificant. And every once in a while, something really amazing. Here's one particular statement. Don't rub your eyes. That's over 1 million times performance improvement for that single statement. Like I said, hold my beer, watch this. Thanks for your attention. We're going to have a white paper coming out pretty shortly on this, and we're definitely going to have that information in there.
Wow, Jim, that was an impressive performance improvement, especially the hold my beer, watch this part.